Great, it's recording now. So let's go ahead over review for exam number 2. I'm gonna go over the main forms. I will skip questions that are similar, okay? But if you feel like I should go over a question that I am skipping, just let me know. I will take care of that. All right, first question deals with complex numbers. They are asking you to compute the square root of negative 81 as a complex number, right? And we know the technique. We just separate 81 from negative 1, right? This way. Welcome, Lucero. Welcome, Hughie. We just started with a review for exam 2. Okay, great. I hope you guys are doing well. All right, so now distribute your square root. And this guy is square root of 81 is just 9. A square root of negative 1 is the unit imaginary number I, right? I. Okay, great. So therefore, this is it. Very good. Second question, similar. So we follow the same technique. We separate 45 from negative 1. So distributing the square roots, this is what we get. But the difference is here, right? This square root of 45 is not exact. So you have to recall those techniques that you learned in previous courses to simplify this type of square roots, right? 45 can be written as square number 9 times 5, and a square root of negative 1 is just I. So we are talking about a square root of 9, 3. A square root of 5 is not exact, it stays the same, times I, right? Times I. So therefore, this is it, right? Very good, excellent, that's it. Number 3, deal with adding complex numbers. I gave you a hint. I said when you have to add complex numbers, simply remove parentheses, right? Treat these two complex numbers as if they were binomials, right? You are adding. So just remove parentheses, right? And simplify this, right? Plus 8 plus 3, 11. Negative 3i plus 5i, twice I or 2i, right? And this is it. This is it, right? Very good, very good. Subtraction, similarly, there are formulas, but we explain in class, right, during the lectures, that it is preferable just to simplify this expression, thinking of these two complex numbers as binomials, right? Look, there is an invisible negative 1 here. Distribute that. This will be plus 8, negative 1 times this, negative I, and then just simplify, right? 3 plus 8 is just 11. 4i minus 1i, 3i, right? 3i. Very good, and that's it. All right. Very good, guys. Moving on, another addition, but this is similar to what we did before, right? So we're similar. Let's go ahead and deal with this multiplication now. Let's recall how to multiply two complex numbers. Again, I gave you a formula in case you want to follow the formula while lecturing, right? But indeed, we said in practical terms, you just FOIL this out, right? FOIL this out. Minus 6 here, 3 times negative 6, negative 18i. Negative 2i times negative 2i plus 4i. And negative 2i times negative 6i, positive 12i squared, right? Now, this I squared, we know is equal to negative 1, right? Because a square root of negative 1i squared negative 1. So yes, substitute that for negative 1, combine like terms. This is going to become negative 12 because it's negative 1, right? So we're going to combine this negative 6 with the negative 12 and quickly get here negative 18 minus 18 plus 4 minus 14i, right? Minus 14i. So for number 6, we are talking about this guy, right? Very good. Moving on, is squaring a complex number. For the sake of variety, let's go over this. We explained in class that the way you handle this, the way you deal with these squares of complex numbers is this, right? You multiply the complex number by itself. But multiplying the complex number by itself, we said, is achieved by foiling this out, right? It's like multiplying binomials. 4 times 4, 16, 4 times negative 8, negative 32i. Negative 8 times 4, negative 32i. Negative 8 times negative 8, positive 64. I times I squared, right? I squared. This I squared, do not forget, is just the number negative 1. So what you're going to get here is 16. Minus 32, minus 32, minus 64. Don't forget the I there, right? We are combining like terms, and here I have negative 64 because of this negative 1. Once you subtract 16 minus 64, that should be the real part, right? Followed by minus 64i, right? 16 minus 64 is just minus 48. Minus 48. So write this here, and that's it, right? That's it. Minus 48, minus 64, 47, answer D. Yeah, any comments, any questions, just let me know, guys. Great, great. Moving on. We should pick one for division of complex numbers, right? I'm going to pick this one, and this should be similar, right? So similar. And let's just do this. Number 9. When you divide two complex numbers, remember, during the lectures, I said there is a formula, but it's very complicated to remember, right? Instead, we said multiply top and bottom by the conjugate of the denominator, right? The conjugate of the denominator. Formally speaking, the complex conjugate, right? Complex conjugate of the denominator, which is the 7. You change the sign of the second component, right? The imaginary part, you get this. But you gotta multiply the numerator and denominator by that complex conjugate. So start here on the numerator, you're gonna get 21. 7 times 4 minus 28i, right? Here, minus 12i, minus 4 plus 16i squared, right? I squared. And don't forget that this I squared is simply the number negative 1, right? Great. On the denominator, 49 here first, then 28i. 28i, but now negative, right? And negative 4i times negative positive 4i is minus 16i squared. I squared again, negative 1. Now, when you multiply a complex number by its complex conjugate, the second term and the third term, they always cancel. So this 0. On the numerator, we will have 21. This is going to be minus 16, right? 21 minus 16 is going to be just 5, right? 5. Minus 28, minus 12, minus 40, I, right? I. Here, 49, minus and minus plus 16. When you add these two numbers, 49 and 16, you're going to get 65, okay? 65. 65, and on the numerator 5 minus 40i, right? Great. So now, remember, mathematicians always want to clearly separate the real part of the complex number and the imaginary part of the complex number, right? So that is achieved by distributing the division here. And once you do that, simplify. Divide by 5, numerator, denominator, we will get 1 over 13. Minus divided by 5, 8 over 13, right? 5 into 65, 13. Okay. Yeah, you can use the calculator in case you don't remember that, right? Yeah, great. So this is it, right? This is it. So therefore, you should choose this for your answer, right? Be careful when you choose for your answer, guys. The choices will be very similar on the exam, so be careful, take your time, choose the one that precisely is the one that you got, right? This one's similar, right? Similar. So let's move on. So we can cover at least the main forms. This one, solve this equation, right? For the sake of variety, let's just do it quickly. Solving this equation can be done by subtracting 100 in both sides, right? Here 0, here minus 100. Then we take square roots in both sides, right? Plus minus here, remember, this square root takes care of the exponent, so we get x equal plus minus the square root of minus 100. But this as a complex number is just plus minus. The square root of -1 is I. The square root of 110, right? Plus minus 10i. So two solutions here, x equal 10i or x equal -10i, right? So that's it. So mathematicians put this together with braces, right? Separated by commas, right? So that's it for 11. Great, moving on. You might encounter questions where you will have to solve quadratic equations such as this. And you may have to use complex numbers. I see a question on the chat. Let me read it. Let me read the question. Why is it plus and minus? Yeah, that's a question by Ali. The reason is this, Ali. Notice, in general, right? Let's look at this. Why this is plus minus? See, if you let's say we have x squared equal 9, right? Notice that if you look for numbers that is when a squared give you 9, the number 3 is one of them, right? But also another one is -3 because -3 squared also 9, right? So this and this. So mathematicians figure out that when they encounter this form, they have to do this, plus minus the square root of 9 to capture these two guys, right? So you don't lose solutions. You follow, Ali, now? That you have to do always plus minus 3, right? Plus 3, minus 3. Very good. Yeah, it's a good question, right? Yeah, guys, ask yourself these what if questions, clarify everything so that everything will be crystal clear when you take the exam. Very good, excellent. Yeah. All right, so yeah, this is just reference, right? Reference. This is something on the side. All right, great. Now, I said, right, you may have to use your knowledge of complex numbers when you solve these quadratic equations. Remember, for a quadratic equation, such as ax squared plus bx plus c equals 0, the solutions are given by this so-called quadratic formula, minus b plus minus the square root of b squared minus 4ac over twice a, right? If you don't remember this formula, write it down and have it handy there when you take your exam 2. All right, so let's apply the formula. A is equal to 1, invisible 1, B is equal to 12, and C is equal to 45, right? Now, if you put all this in your calculator, you will get minus B minus 12 plus minus B squared, 12 squared, minus 4AC, 41 times 45, over twice A, twice 1, right? But now, look at this, guys. This will be equal, let's continue here, okay? X equal 2 in the denominator, minus 12 here, plus minus what? The square root of what? Let's compute this, the inside of the radical, right? Let's compute it in our scientific calculator. 12 squared 12 squared minus 4 times 1 times 45. It's a negative number. It's negative 36, right? Negative 36. Negative 36. But we know how to handle these square roots of negative numbers, right? We have now complex numbers to help ourselves out. So this turns out to be just 6i, right? 6i. Why the I? Because of this negative. We did an example before, right? 6i is a complex number over 2. And then simply divide 2 into 12 into 6. And you should get your answers there. Minus 6 plus minus 2 into 6, 3, right? 3. That's it. Plus minus 3i. So two solutions here. X equal minus 6 plus 3i. Or perhaps x equal minus 6 minus 3i, right? Minus 3i. So you got to choose the one that is showing both together, separated by commas, inside braces, right? So it's this, right? Yeah, great. Yeah, plus and minus this, 4, 12. Yeah, excellent, excellent, right? Yeah, very good, very good. Okay, moving on. And again, guys, if you have questions, just let me know, okay? Great. Welcome, Julie. We're working over the review for exam 2. Okay, this one's similar, right? Similar. Do it at home. Similar. Use your knowledge of complex numbers. If need, but however, this deals with another topic, so we should do it. I think it deals with finding the vertex. So number 14, yeah, it's different. So find the vertex and axis of symmetry of the graph of the function f of x equal x squared minus 6x plus 8. It is a quadratic function, right? We know that the graphs of quadratic functions are parabolas, right? Either opening upward or downward, right? Depending on the sign of this leading coefficient. This has a equal 1 positive, so you expect a parabola opening upward, right? And we explained that once you identify A, invisible one here, and B, there is a formula to get the vertex of your parabola, right? And what is that? You start by computing this minus b over twice a. This will be the first coordinate of your vertex, right? Which is this, minus and minus plus, 6 positive divided by 2 times 1, 2 is just 3. This is the first coordinate of your vertex, and then you plug this into your quadratic function here to find its partner, right? Its partner, which is going to be the second coordinate of the vertex. So this computed is what? 3 squared is 9. 9 minus 6 times 3, 18 is minus 9. Minus 9 plus 8 minus 1, right? Conclusion, vertex equal 3 here, first coordinate, right? Let's write here big 3, comma, this guy, minus 1, right? Partner. This is the vertex. And also we said that the axis of symmetry is given by this equation. X equal, you pick up the first coordinate, 3, right? X equals 3. So combining these two results, clearly, yeah, let me see. This is negative. Equal minus 3. Yeah, let's double check here. Yeah. I wrote this negative is positive, right? It's positive. So be careful, they're positive. So let's erase this so nobody gets confused. But this will make this negative. Yeah, guys, during the exam, you may get into these situations, right? If something doesn't make sense, just don't panic, just check and, review what you have to review, and everything should make sense afterwards. So this was then, I copied this one, is positive, right? Yeah, let's put positive. So negative 6 divided by 2 is negative 3. I'm plugging negative 3 into the formula, gives you this as 9 minus 18 minus 9. This is -1, right? But this is -3. So -3 and -1 should be the coordinates. And the axis of symmetry, you pick up this guy and you just put here. This is the axis, what determines the axis of symmetry, right? X equal -3. So we're talking about this guy, right? Now it's good. Very good. That's how you find axis of symmetry and the vertex, the coordinates of the vertex. Here, another question related to the same topic. They want you to graph this, right? Graph this. So how you do that? Well, compute minus b over 2a quickly. A here is 1, b here is 4. So minus 4 over twice 1, minus 4 over 2 minus 2, right? And then substitute this minus 2 into your quadratic function here. So minus 2 squared plus 4 times minus 2. This is 4. 4 minus 8 minus 4, right? Minus 4. So conclusion, vertex equal minus 2 comma minus 4. And axis of symmetry should be just x equal -2, right? Axis of symmetry. Very good. So x equal -2. So basically at -2, you draw your axis of symmetry there, but also you set -2 comma -4 to be your vertex, right? So -2 here, notice that each of these is 5, right? The half is 10, then 5, right? So somewhere around down here should be this, the vertex, right? From there, notice the y-intercept should be given by letting x be 0 in here. If you let x be 0, f of 0 is clearly 0 squared 0, 4 times 0, 0. So 0, comma 0 is the y-intercept, right? Y-intercept. The y-intercept is here because of the symmetry with respect to the axis of symmetry. Over here, you must have another point, right? With these 3 points, you can draw the parabola, right? So that's it. Yeah, and then if you look at this among the choices, the answer should be this one, right? Look, vertex, this. And x-intercept 0, 0, and -4, -4, 0, right? So on the graph. Very good, guys. So B. Excellent. Let's look for new forms. Determine whether there is a maximum or minimum value for the given function and find that value. This deals with maximizing or minimizing your quadratic function, right? Remember, there are 2 possible scenarios. One scenario is the happy phase, when the leading coefficient A, which is 1 here, is positive, right? This leads to a happy phase. So just remember the shape of the mouth of the happy phase, right? That would be the graph of the parabola. So clearly here, we're looking for a minimum. But then we said that that minimum occurs at minus b over twice a, right? At this value for the input values of your function. So we do minus b, which is 4, over twice a, which is 1. This is -2, right? -2. Next, to find the partner of next -2, you know, we have found where this happens input wise, right? But we want the output value, right? To see the actual value of the minimum. So just plug this into your function. That's all you do. So f of -2 will give you the minimum value. So -2 is square plus 4 times -2 minus 3, right? So this is 4 minus 8 minus 4 minus 4 minus 3 minus 7, right? Minus 7. So for 16, minus 7 should be the minimum. Very good, excellent, guys. This one is similar, but instead of finding the minimum, you will find the maximum, okay? So you're gonna use similar, try to do it. It's a frown phase, right? But the maximum now will occur also at minus b over 2a, you find it, and then you plug it into your quadratic function, and you should get the maximum value. Very good. Number 18. Number 18 deals with maximization again. They say a rock is propelled upward, right? Somehow goes up to some maximum height and then goes down, right? They want you to figure out what is the maximum height, right? That's maximum value. They give you the function that relates position at a given time, right? Which is this. Comes from physics, right? So, and they are basically asking you to maximize this function, right? You may say, Professor, how do you know this opens downward? Well, because this is negative, right? Negative, yeah, front face. Yeah, very good. So, but again, minus b over 2a is where the maximum will happen, right? Maximum value at this, maybe I should write, right? At maximum at x equal minus b over 2a. But what is b here? Is 72. Twice a is minus 16. We're gonna compute this guy in the calculator, right? Take your calculator and compute it. Okay. Great. Welcome, Kang. We are working on the review for exam 2. Don't worry about the signs. Negative divided by negative is positive, right? Let's focus on the numerical part. So minus 16 here. And I get this value, 2.25. This is telling me that at 2.25 seconds, the maximization will happen. This is 2.25, right? But they don't want the time at which the maximum value happens. They want the actual maximum height, right? So we're gonna evaluate this guy, right? Again, remember the technique, evaluate this into your function. Your function is now this s of t, right? So plug 2.25 seconds into your function. And as a result, you will get this, right? Negative 16 multiplied by 2.25 squared plus 72 times 2.25 plus 150, right? Plus 150. Let's compute this together, right? Get your scientific calculator, the one that you're using, or use our Desmos scientific calculator, right? Strongly recommend you to do that. It's free. OER plus 72 times 2.25 plus 150, right? Yeah. 231. And in the end, attach the units, right? 231 in the end, attach the feet, right? So 231. It's this guy. Yeah, everything clear, guys? Very good, very good. The next is similar, but instead of maximizing, you have to minimize, right? Minimize because this is a positive, so it's a happy face, you minimize, but similar. Use this technique, right? Minus b over 2a will give you the input value, and then plug whatever you get from there into the function that will give you the maximum or the minimum value. Let's move on. Number 20, similar also, right? This is maximization problem. This one similar, maximization problem. Let's go ahead with 22. Determine whether the graph shown is a polynomial, the graph of a polynomial function. Well, remember, for the graph of a polynomial function, it has to be a smooth, right? Smooth, all in one piece. This is only one piece, but this is not a smooth corner, right? Corners are no good for polynomial functions, so we're gonna say not the graph of a polynomial function, right? Yeah, it's not smooth, not smooth, yeah, because of the corner, right? Great. Moving on, guys. This one, is this the graph of a polynomial function? Well, let's check smoothness. It is smooth. Let's check if it is all in one piece. It is all in one piece. And let's recall, right, that the graph of polynomial functions, they look either like parabolas or chair-like functions, right? This looks like a parabola, so this is good, right? This is a good one. So it's a good one, polynomial function. What about this? This one, the trouble is that there is a gap here, right? A jump, not connected, right? Not connected. That's not good for a polynomial function, right? Polynomial functions are all connected, so this one, no. Yeah, very good, guys. I hope you remember all this. Moving on. They talk about now the end behavior. For this, I would strongly recommend you to recall that for the graph of polynomial functions, there are just four shapes. Either it will be a parabola-like, right, like this, or perhaps like this, right, parabola-like. In the middle, remember there's some wiggling, but in the end, it will look like this, or maybe chair-like, right, chair-like, like this, increasing chair from left to right, or decreasing chair from left to right. Right, in the middle, some wiggling, doesn't matter. Now, for you to recall this, guys, I strongly recommend you to go to our website and print this out. Look, this is what I just did, right? Look, this is one shape for the graph of polynomial function, right? Parabola-like, open downward, chair-like, right? Chair-like, increasing from left to right, and chair-like, decreasing from left to right. This is under useful sheets under course materials. If you just want to grab it, I can copy and paste the link here on the chat, okay? Yeah, we're gonna use that. So if you wanna just grab it, here is the link. Okay, great. It's in our website. Okay, now they say, right, figure out the end behavior for this polynomial function. And remember, the end behavior of a polynomial function depends on the first term, right, which is called the leading term, right? Just take a look at this guy and at this guy separately, right? This guy is an odd number, right? And this guy is negative. So for odd numbers, the graph must be chair-like, right? But this is negative. This is when the leading coefficient is positive. This is when the leading coefficient is negative. So it's gonna look like this chair, right? This decreasing chair from left to right. And the only one that does that is this, right? Is this. So rises to the left and falls to the right, right? Just like this one, right? Right? You follow, guys? Very good, very good. So, yeah. If you want to use the sheet also, right? This is the one, right? For leading coefficient negative and for odd degree, right? So, same thing. Very good. All right, moving on. We're going to use this again. So let's try to do it again. Yeah, very good, very good. Yeah, so let me just fix this. Close and open again. Very good, very good. So we're gonna use it again now. Okay. Yeah, so all we said was this, right? This was odd. And this was negative, right? Negative. That's why we chose this form, right? This shape. All right, great. Another one here, 26. 26. Not, they don't give the graph, but no problem because you just look at the first term. This time, this guy is even, and this guy is positive, right? Positive. And among the four choices, you have to go with the one that says this will be parabola-like, right? For even exponents parabola-like. And since this is positive, it will be like this, right? Some wiggling in the middle, right? Some wiggling, but eventually will go up. So raises to the right, raises to the left, right? So the one that you have to choose then for 26 is this one, right? Rises to the left and rises to the right. Right? Or again, look at the sheet that I show you, right? This one. And we are talking about this guy, right? Positive leading coefficient and even degree, right? Yeah, look at this guy. Very good, guys. So it's a useful sheet. So this one similar, and this one similar. I will leave this for you to do. Let's move on. Similar. This one also, I would say similar, right? To the first one that we did. Let's use the sheet. we reached to this part that is with finding zeros of a polynomial function, right? Let's say they want you to figure out the zeros of this polynomial function. The technique is set this equal to 0 and solve for x, right? In this case, notice that x is present in each term. So a good idea should be to factor out x, right? Greatest common divisor or greatest common factor. So x into x cubed, x squared, on the right here factor, x into x squared x minus x into 12x, x cancels, 12 stays. This is it, right? This part, guys, these quadratic trinomials, these are trinomials that you learn how to factor in previous courses, right? You just look for two numbers whose multiplication is negative 12, whose sum is positive 1. Those numbers, after some trial and error, will be 4 and 3. You want the sum to be positive 1, so positive 4, negative 3, right? Once you get to this part, you set each factor containing the variable equal to 0. From there, the zeros of your polynomial will come out, right? Plus 3, x equal 3, minus 4, x equal minus 4, right? Notice the final solutions are opposites to the numbers that appear on the factorization, right? Opposite, positive 4 appears in the factorization, negative 4 the solution, right? So don't get confused, guys. This is it. These three together, right? Together. So that is shown on choice A. Very good. This one, similar, but I'm gonna give you a hint. Similar hint, use factoring by grouping. Factoring by grouping. Okay, very good, very good. Next, divide using long division. Remember we went over long division and synthetic division. First, let's deal with long division, number 32. In order to divide these two polynomials, the first one that appears from left to right, it's called the dividend, goes here inside, right? 46x plus 15. The second that appears from left to right is called the divisor, goes outside. Start by dividing this guy by this guy. 35x squared divided by 7x negative is negative 5x, right? Negative 5x. That negative 5x has a place on top of this minus 46x. Then multiply this guy times this whole thing, this divisor, right? When you do that, you're going to get negative 5 times negative 7 is 35x squared. Negative 5 times positive 5 minus 25, don't forget the x, right? And then you gotta subtract these two, right? To help myself, remember, I just distribute the negative sign over. You get this, and they get positive 25x, right? These two will cancel as usual, right? But these two, what is minus 46 plus 25? Minus 46 plus 25 is just negative 21, right? Negative 21, you can get it in your calculator in case you cannot do it in your head. Next, you bring the next number, the next term, better said, right? And then you start again the process. Negative 21 divided by negative 7. That's going to be a positive 3, right? Positive 3. That number 3 multiplied by this guy. Positive 3 times negative 7 minus 21x. 3 times 5, 15. I got this to be exactly the same. So when I subtract this from itself, clearly this is 0, right? So this division was exact. So I don't have to mention the remainder. I just mentioned the quotient, right? Minus 5x plus 3, which is this, right? Follow, guys? Great. Next, I think we have to do also synthetic division, right? Here it says divide using synthetic division. Synthetic division can be done when the divisor is special, when it's of a form x with invisible one up front, right? As x plus or minus some number, right? So this is good. So you draw your vertical line, then your horizontal line, and you work with the coefficients, right? 5, 42, 16 here. And in this corner, you write the opposite of this, right? Opposite. Plus 8 has as its opposite negative 8. Then bring this down as it is, 5. 5 times negative 8, negative 40. Adding these two, 40 is 2. Some comment on the chat. Jinjin is asking me about decimal activities. No, Jinjin, I think we did the 3 decimal activities, right? No more decimal activities, right? We did the 3 of them. We're done with decimal activities. No more. Great. All right, great. So continue, right? 2 times negative 8 is negative 16. Negative 16 added with 16, 0, right? 0. So remainder 0. We don't have to mention the remainder. This is going to determine the quotient. How? 2 here, the constant term. And this is the coefficient of x, right? 5x plus 2. So 5x plus 2. Very good, very good. Is there. Continue, right? So I gave you an example for synthetic division. This is also be done with via synthetic division. So this will be similar. This one synthetic division, similar. Synthetic division, similar, right? So good. Now we reach to this part where you have to use the remainder theorem and synthetic division to evaluate this function. This is the function. They want you to do the evaluation at k equal 3. We said that that evaluation can be done using synthetic division. You just write 3 here, right? And here the coefficients 1, minus 5, 3, and 3, right? You start by bringing this down as it is. 1 times 3, 3, add minus 2 here, minus 2 times 3, minus 6, add negative 3, right? Negative 3 times negative positive 3, negative 9, add 3 plus negative 9, negative 6, right? Separate the last number from the rest. That's the remainder, right? But the remainder theorem says that this number, besides being the remainder, is just the evaluation of your function at 3, minus 6, right? The evaluation. Great. Okay, guys, very good, very good. So far, so good. Now, let's talk about how to use synthetic division to find all zeros of a polynomial, especially if the polynomial is degree 3, degree 4, right? So you have this polynomial, they give you this hint, divide by x plus 8, divide by x plus 8, right? So let's start there. If you're going to divide by x plus 8, you have to consider the opposite of this guy here, right? In the corner, opposite. So that would be negative 8, right? Negative 8. Here, there is an invisible 1, right here, 1, 15, 68, and 96, right? These are the coefficients of the dividend. You start by bringing 1 down as it is. 1 times negative 8 is negative 8. Add these two. That's just a 7. 7 times 8 minus 56 here, right? Adding these two, which is negative, you actually subtract, right? So you're going to go 2 here, 1 here, right? 12. 8 times 12 is negative 6, but it's a negative sign, minus negative 6, leaving you a remainder 0. So what does it mean? It means that this function, this cubic function, right, can be written in factor form in this way. Look, this guy multiplied by the divisor, right? So x plus 8 here, multiplying the dividend here, right? Or the quotient, better. This is the quotient, right? Yeah, the quotient is this. 12 constant term, 7x, and here x squared, right? 1x squared. This is it, right? This is the factorization of the polynomial. So let's continue factoring, right? Using our knowledge from previous courses. This one x here, x plus 8 here. Two numbers of multiplication is 12 to sum is 7 are 4 and 3. 4 and 3 positive both. So I got my full factorization, right? My full factorization. From there, if you set f of x equal to 0, clearly you can get all your zeros, right? Which are going to be opposites to these numbers that appear on the factorization, right? So x plus 3 equals 0 will lead to x equal -3, first zero, right? X plus 4 equals 0 will lead to x equal -4, second zero, and x plus 8 equals 0 will lead to x equal -8, third zero, right? These three guys within braces separated by commas should give you the answer to this question, right? For 38. Be careful when you choose your answer, guys. Look, they're very close to each other, right? So make sure you're choosing the right one. They're all negative, right? In any order, right? So the order is not relevant. Very good. Continue. Let's see 39. 39 is similar, right? Should do this process I did there with this x plus 7. You should be fine. Similar. Continue with 40. Let's see 40. Also similar, I would say, because they say that you have to use synthetic division starting with this number 4, right? This is one of the zeros, so you start with that. And then you continue, you do what I did here, right? Get the full factorization, and then you get all the solutions. Similar. 41. Also similar, right? You start with 3 in the corner, and then maybe I should write this as a hint right here. Start with 4 in your corner, right? Here start with 3 in your corner, and then factor, and we will find all the solutions similar. Great. 42 deals with, this is a little bit different, so let's do it. Deals with figuring out all possible rational zeros for this function, right? And we explained that that depends exclusively on the first term and the last term, right? And to be precise, depends on the divisors of the first term, the leading term, and the divisors of the last term, right? This guy. So these possible zeros, rational zeros, to be precise, are given by this. Divisors of this, 15, plus minus 1, plus minus 2, I cannot write, plus minus 3, right? Divisors of 15, plus minus 5, and plus minus 15 itself. These are divisors of this guy. Maybe I should write it in this so you can make the connection there. Now, divisors of this guy, what could it be? Just plus minus 1, right? Plus minus 1. So writing this into each of these, or dividing this one into each of these, leads to the same list, right? Which is the list of possible rational zeros of this polynomial function. And that's it, right? This is it. So you're gonna go with this guy, right? 42. Very good, excellent. Yeah, here another one. For the sake of variety, this is gonna be similar because it has one here. So, but this one probably should be interesting to do, similar. Here, notice the leading term is -2 and the coefficient term 8. So the possible rational zeros of this polynomial function will be divisors of 8 on the top, so plus minus 1, plus minus 2, plus minus 4, and plus minus 8, divided by divisors of this guy in the bottom, right? Divisors of this guy in the bottom. So maybe we should color this with this. In the bottom, look, I have to have divisors of -2, plus minus 1, but also plus minus 2 now, right? So now, if you divide 1 into each of these, you're going to get plus minus 1, 1 into 2, plus minus 2, 1 into 4, plus minus 4, 1 into 8, plus minus 8, right? Done with this guy. Now, let's do the same with the number 2. 2 into 1, plus minus 1/2, right? 2 into 1. 2 into 2, plus minus 1. But plus minus 1 is already here, right? So you don't have to write it again. 2 into 4 is plus minus 2. It's already there. We don't have to write it again. 2 into 8 plus minus 4 is already there. We don't need to write it again. So turns out this is the whole list. Now that list, mathematicians often write it starting with the smallest in absolute value, right? Which would be this 1/2, right? So often they write, okay, the smallest in absolute value 1/2, then 1, then plus minus 2, then plus minus 4, then plus minus 8, right? Ascending order in absolute value. So you gotta go with then this guy B, right? Follow, guys? Great. This question now is a little bit different. Let's check that. Yeah, I think we can do this one. It says, given the polynomial function f of x, find the rational zeros, then other zeros, that is, solve the equation f of x equals 0 completely, right? Yeah, great. It's a good question. Let's do it. So in order to do that, in order to find all possible zeros, right, and show also the factorization, the full factorization is shown here, right? You should start by figuring out what are the possible rational zeros of this, right? But notice, guys, you have to work efficiently, right? If I do that, look, the divisors of these guys are a lot, plus minus 2, plus minus 4, plus minus 8, plus minus 16, a lot. Divisor of this plus minus 1, right? So I'm going to get a huge list. Instead of doing that, I give you this advice. Look at the possible solutions here. There are not so many, right? Look, there is a minus 4, a minus 8, minus 4, 4, minus 4, minus 4, 4, and 8. Try with these guys, right? 1 is not going to work. Obviously, it's not there. Plus minus 1, plus minus 2, not going to work. Start with minus 4 or plus 4, right? Start, work efficiently. All right, so we're going to start with negative 4. What about negative 4, right? Or you can start with positive 4, doesn't matter. Negative 4, I'm going to test if negative 4 is a solution or a zero of this polynomial function. 1, notice, this polynomial is incomplete. It's missing the square term, right? For that, I'm going to write 0 times x squared. Then the rest is okay. Then this one is minus 48x minus 128. So this will be 1, remember? Then 0, the 0 is important there, right? Minus 48 minus 128. Let's test negative 4. Let's see if it's a root or a 0 of this polynomial function. 1 comes down as it is. 1 times negative 4, adding these two, negative 4 times negative 4, positive 16. Positive 16 plus 48 is 32 negative, right? 4 times 32, positive 128. Adding these two, 0. Great. This is one of the zeros. From there, guys, you can say the following. You can say that this polynomial function f of x can be factored as this guy multiplied by the divisor. Now you are dealing with we were having in this quarter negative 4, right? So when we write this as a binomial, as the divisor, we have to write here opposite, right? Opposite. Plus 4. You follow, guys? Opposite. What appears here in the factorization and what appears in this corner, opposite to each other. Always. All right. Now over here, I get this from here, right? Maybe I should color this. This is what I'm going to write here. The quotient is negative 32 is the constant term, minus 4x, the x term, and 1x squared, which is written as x squared, the square x squared term, right? So it's this. Now, we learned in previous courses how to factor this guy, right? So let's do that. X here, x here. Two numbers whose multiplication is negative 32 and whose sum is negative 4. After some trial and error, you will find out that those numbers are 8 and 4. I want the sum to be negative, so this should be negative, this should be positive, right? And I get an interesting full factorization here. Look, notice this guy is repeated, right? But if you follow the rule to find all the zeros, which is set f of x equal to 0, then x plus 4 times x minus 8 times x plus 4 equals 0, leading to the following, right? X plus 4 equals 0, x equal negative 4, 1, 0. X minus 8 equals 0, x equal 8, another 0. X plus 4 equals 0, x equal negative 4, another 0, right? This 0 is repeated, right? It's repeated. So let's mark this repeated. Look here and here. Multiplicity 2, right? So in reality, there are just two zeros, 8 with multiplicity 1 and negative 4 with multiplicity 2, right? 2. So look for that. And also notice that the full factorization, the full factorization can be written as follows. If these two are the same, I can write just this to be x plus 4 is square, right? Square, followed by this x minus 8, right? This is the full factorization. So look at this full factorization and look at the zeros, right? Which show multiplicity 2, one of them, and find the answer then, right? So what should be the answer there? For number 45. See? Let's see. This one looks good. Negative 4 with multiplicity 2 and 8 when the multiplicity is 1, they don't write the multiplicity, right? So, and this is the full factorization. So we're talking about choice A, right? You follow, guys? Yeah, great. Let's continue with this question 47. It says f of x equal x cubed plus 3x squared plus 25 plus 75. They want you to find all its zeros, all of them, right? Real and complex, all of them. So hint, guys, start by testing your synthetic division with this number. Look, negative 3 is one of them, right? It's rational. This square root is not a rational number, right? Remember, it's irrational. So test with these guys. The negative 3 seems to be a good candidate, right? Start with that. Let's see if this is indeed one of the roots. So this is 1, invisible 1 there, 3, they have 25, then 75, right? 1 comes down as it is, 1 times negative 3, adding these two, 0. 0 times negative 3 is 0. 0 plus 25 is 25. 25 times negative 3, negative 75, right? And negative 75 plus its opposite 75, 0, 0. It confirms that this is one of the zeros, right? Good. But now this allows me to factor this f of x as follows. Look here, x, you get this number negative 3, and you write there the opposite, right? Opposite. Right? Negative 3 is the 0, but in the factorization, on the binomial factor, this appears as plus 3, because remember you said this equal to 0 to get you 0. Great, opposite. Now, what goes here? This guy. So, right, from here you get your quotient. So 25 is the constant term. 0 times x disappears, right? So maybe I should write it so nobody gets confused. And 1x squared, which is written as x squared, right? This is it. But simplifying this part, this is 0. This is just this, x squared plus 25 times x plus 3, right? Now, I have to set each factor equal to 0 to solve this, right? And you may say, Professor, why don't you factor this? Guys, this is unfactorable. The one that is factorable is when you have minus here, right? Difference of squares you can factor, but this you cannot factor. So just set it equal to 0, following from this, right? When you set f of x equal to 0, you end up setting equal to 0 each factor containing the variable. From there, look, negative 25 here, negative 25 here, leads to this, x squared equal negative 25. And taking square roots in both sides, don't forget to write plus minus here, leads to this, x equal plus minus what? Plus minus a square root of negative 25. But what is that? A square root of negative 1 is I, a square root of 25 is 5, right? So 5i, plus minus 5i here. And from here, I get this -3, x equal -3. So this is 1, 0. And from here, I get 2 zeros, x equal 5i and x equal -5i, right? So these are in total all the zeros of these polynomial functions. X equal 5i, x equal -5i, x equal -3. So you gotta write this out, but also somehow they want you to factor, right? To show the full factorization here. So once you have your final zeros here, one way to go back to the factorization is this. Write the opposite of this, opposite. Opposite would be -5i, right? -5i, opposite of 5i. Here, opposite x plus 5i, right? And opposite of this x plus 3, right? And then we are done with the factorization. And also we know that these are the 3 zeros. So clearly the solution should be this guy, right? Look, zeros are -3, -5i, plus 5i, together with this factorization, this full factorization, right? The 3 factors are there. Very good, guys. All right, let's move on with 48. It talks about end behavior. It says use the graph of the rational function shown to complete the statement. They want you to figure out as x approaches 1, this negative sign on the top means from the left, plus means from the right. As x approaches 1 from the left, where is f of x going to, right? What f of x approaches? Well, -1 is here, right? No, not 1, right? 1 is here. And maybe if I increase this a little bit, you can see that if you approach 1 from the left, then you have to go kind of like this, right? And if you see where the output value is going, it's clearly going to -infinity, right? -infinity. So you gotta answer that this guy f of x approaches -infinity, right? Because this is what you see here in the graph, right? Try to be close to 1, very close to 1. Very good, guys. So therefore, this is it, right? Yeah, great, excellent. So now let's continue. Continue here. 49 talks about asymptotes, finding asymptotes, find the vertical asymptotes, if any of this graph. For vertical asymptote, we said simplify first and then set the denominator equal to 0. This is already simplified, right? There is nothing else to simplify. So you set x minus 5 equal to 0. From there, you will get that your vertical asymptote is precisely x equal 5, right? It's determined by the equation x equal 5. Talking about this, right? Excellent. That's 49. Then 50 now. Another one. This one is tricky, guys. Be careful with this. They ask you to find the vertical asymptotes. First, simplify. Very important, right? Simplify. In this case, turns out this h of x rational function, once you factor the denominator, admits some simplifications. Look, I factor the denominator as x minus 6 times x plus 6 using difference of squares. But when you do that, notice this x plus 6 can be canceled. This. So what is this saying? This is saying that h of x in reality is not this complicated function. It's a simpler function. It's just this. So now in this function, you set the denominator equal to 0. Okay, in this function, not in this, right? Because you're gonna be misled there if you do that. So here, there you can get that the vertical asymptote is just x equals 6. Only one vertical asymptote, right? That's it. So this is this guy. Very good, guys. So moving on, this is 50, 51 probably. Let me see. Yeah, this is similar, but here once you factor the denominator, right, which is this factor, you get x here, two numbers with multiplication is 24, whose sum is negative 11, 8 and 3 after some trial and error, and both negative, right? And now you try to simplify, you see that nothing is simplified. So now you simply set the denominator, set denominator equal to 0, right? And from there, this time we're gonna get two vertical asymptotes, one coming from here, once you set this equal to 0, x equal 3, and the other coming from here, once you set this equal to 0, x equal 8, right? These two guys are gonna be our vertical asymptotes. So therefore, when you choose your answer, you should go here, right? B. Very good, guys. Now find horizontal asymptotes now, no vertical asymptotes, horizontal asymptotes. For that, remember I explained in the lecture, you have to determine if the rational function is bottom heavy, equally heavy, or top heavy. This is clearly bottom heavy because of these two, right? Bottom heavy. And we said that for bottom heavy rational functions, the horizontal asymptote is just y equals 0, right? Because this outruns this, y equals 0, so this, right? 52. Then we talk about these functions called equally heavy, because look at the degree, 2, 2, right? Equally heavy. And for these equally heavy rational functions, we said that the horizontal asymptote is determined by the quotient of these two leading coefficients, right? So it will be y equal 4/8, but 4/8 simplified is just 1/2, right? 1/2. So y equal 1/2 should be our answer there, right? Follow, guys? Yeah, very good, very good. This one happens to be top heavy because this 3 bigger than 2, right? Top heavy. As we said in the lecture, right? Top heavy. For top heavy, then no horizontal asymptote, right? No horizontal asymptote. That's the rule, right? So we go with this. It's 3 scenarios, right? Remember, guys. Okay, then they want to ask you to some graphing here. I have two questions that are similar, 55 and 56. I'm going to choose this time 56 because I think 55 was done in the lecture. Okay, this is similar to the one that I want to do next. This one now for the sake of variety. So they say they want you to graph this. Start with the asymptotes right away. What are the vertical asymptotes? Look, this is in simplified form. And on top of that, if you factor your denominator, right, you get the following: x minus 2 times x plus 2, right? So from there, setting your denominator equal to 0, you're going to get your two vertical asymptotes, two vertical asymptotes, okay? So turns out the vertical asymptotes are very important here. X minus 2 equals 0 leads to x equal 2 as a vertical asymptote. And x plus 2 equals 0 leads to x equal negative 2 as a vertical asymptote, right? Two vertical asymptotes. So quickly, just put them there, right? 1, 2 here. This is one vertical asymptote. At x equal 2, VA. And at x equal minus 2 here, another asymptote, right? These asymptotes are going to determine the structure of your graph. You will see vertical asymptote. Now, what about horizontal asymptotes? Look at this function. Is equally heavy, right? Equally heavy. Equally heavy, right? Same degree, 2 and 2. So horizontal asymptote should be y equal the quotient of these two, 2/1, right? 2/1, but 2/1 is 2. So y equal 2 is the horizontal asymptote. Let's choose a different color. So here, the horizontal asymptote, right? Very good. So these are going to be like the structures for your graph, right? And turns out they're very important. And then you have three regions here, the left, the center, the right. I said use test points to help yourself to determine if it's this curve or this curve, the one you have to choose for this part, right? Because it's asymptotic here, asymptotic here. There are just two possible ways for that to happen. So if you use test points, for example, 5, you can use test point 3, 2, any number really, you will see that using the test point, for example, 1, 2, 3, right? And you evaluate your function at 3, what are you going to get? Using test point 3. Look here, 3 squared. This we can do it here, I think, in the calculator, right? 2 times 3 squared divided by 3 squared minus 4. 3.6, right? 3.6, something above the 2, right, that we have. So above, so clearly this guy ends up here, right? So this is telling us that the graph over here should be like this, right? Asymptotic here. Don't get obsessed trying to come up with a perfect graph. It's just a sketch, right? So do your best there. Details of this graph will be achieved when you got more tools in calculus, right? For now, this will be good. Now, for this part, similarly, right, if you take as a test point -3 now, -3, let's do that, right? F of -3, let's see what we get. Yeah, so 2 times -3. We're gonna get the same value, right? The same value because the square of 3 and -3 is the same, right? It's the same. So -3 squared minus 4. 3.6 again, right? 3.6 again. So it's the same. So 3.6, 3.6. So this tells you that this guy, the -3, which is here, right, will have an output value here as well. So this tells you that this is the curve that you have to take, right? This part. Now, to the origin, that this curve must go through because the x-intercept, y-intercepts are 0, 0, right? If you let x be 0, notice y is 0. So this is a point of the graph. Now, taking test points 1 and -1, for 1, notice 2 times 1 is 2, 1 minus 3 is -3. So we get a negative value, right, down here. And the same for -1, right? Because -1 squared and 1 squared are the same. So using test points 1 and -1, you can find out that the graph has to go to these 2 points. X-intercept is 0. So this is it, right? And if you want to see details of this process, just go to the lecture that corresponds to rational functions. We did that, right? So this is it. But I want to emphasize the asymptotes. Look, when you look at the choices, which one is showing the asymptotes? The only one is this, right? Look, the 2 vertical asymptotes at x equal -2, x equal 2, 2 minus 2, and then at y equal 2, the horizontal asymptote, right? So see how important the asymptotes are, right? So this guy. Yeah, this other, do it at home, is similar, okay? Try it at home. Very good. So moving on. Now let's talk about the slant asymptotes, right? Remember, for the slant asymptote, we said that the way you get it is by using synthetic division, right? So for example, here I have 1 invisible 1, 3, and -7. And over here, since the divisor is x minus 9, I write the opposite 9, right? Opposite 9, the coordinate. I do the division via synthetic division, and the quotient will be per se will determine the slant asymptote, right? So let's do that. 1 here, 1 times 9, 9, 9 plus 3, 12, 12 times 9, 108, and this difference 101. This is not relevant, you neglected. What is important is this part. This part. So your slant asymptote will have this equation, y equal 12 constant 1x squared, not x squared, 1x, right? 1x. You don't have to write one. Y equal x plus 12. That is what we call the slant asymptote, right? Very good. Very good. All right, great. So, and you may say, how do you know there is a slant asymptote? We explained in class, this is top heavy, right? Top heavy rational functions. When the difference of the degrees is 1, they show a slant asymptote, right? Good. Now, here is another one. This is similar, so you should do it at home. Similar. Here's another one where they ask you to graph this, right? A rational function showing a slant asymptote. So I explain quickly, get the vertical asymptote. Vertical asymptote will be by setting the denominator equal to 0, the line with equation x equals 0, right? Vertical asymptote. And for the slant asymptote, we have to divide these two polynomials. The divisor is really simple, right? Doesn't deserve to be gotten by using synthetic division. Just divide x into x squared, that's x, minus x into 9, 9 over x. This is the remainder, right? Remainder is neglected. Remainder is neglected. Ignore it and keep just this. So y equal x should be your slant asymptote, right? Asymptote. That is this line, right? The slant asymptote, this diagonal line, y equal x. That's the slant asymptote. And the vertical asymptote, it's at x equals 0, this guy, right? Vertical asymptote. So now we have two possible scenarios. One is the curve may go asymptotic here, or perhaps the curve may go asymptotic here, right? We don't know. But in order to find out, use test points. For example, is the test point 1, f of 1, computed in your calculator. Look, f of 1 will be 1 minus 9 over 1. 1 minus 9 minus 8, right? Minus 8. You follow, guys? Yeah, so again, I'm using 1 as a test point. I plug it into here, 1 squared 1, 1 minus 9 minus 8 divided by 1, negative 8. It's negative, it's a negative number. So it's showing me that I have to go all the way down here to negative 8, right? So negative 9, negative 8 is here. So this guy should be somewhere down here. Aha, point here. So therefore, the curve, look, has to be like this, right? In order to contain that point, right? Because if I choose this curve, it's gonna miss this point, right? That my test point game. Now, using this point now, -1 here, -1. What is f evaluated at -1? -1 squared 1 minus 9 minus 8. Minus 8 divided by -1, positive 8 now, right? Positive 8 now. So this one negative should go pair up with 6, 7, 8, with 8. Here now. So in order not to miss this point, I have to choose this curve now, right? This one. The asymptotic here, asymptotic here. It's vertical asymptote, isn't it? So if this is the graph, when you look at the choices, you will find that there is not this, it's not this. This one, right? So be careful there, guys. Depending on the test points, you will have the given choice, right? Yeah, very good. Then we talk about exponential functions recently, so let's try to review that part too. First, this is computational, so we're going to skip, right? This, I hope everybody's okay computing this in the calculator, right? So skip this. This is a graph. Yeah, maybe we should try this one. What is this graph? Well, look at this part, which is something well known. It's just this guy, right? y-intercept at 0, 1 and going like this, right? This is g of x equal phi to the x. Plus 2 means 2 units up, right? 2 units up, 2 units up. It's a shift, right? So move this up. When you move it, I explained, move the main point. This blue point in the new graph will appear 1, 2 up here, right? Appear here. And this horizontal asymptote, when you shift it up 2 units, will appear here, right? So right there, draw again your curve. This, right? Right? And then you will see that the graph is just this guy. Great. Next, let's see what's coming up here. I have another one. It's try to use here a reflection is similar. Okay. So reflection about the x-axis, right? You remember when the negative sign is applied to the input value, you do the reflection about the x-axis, right? So if you reflect your graph, we said the graph of the function y equal phi to the x is this, about the x-axis, you will get something like this, right? Yeah. Mirror image about the x-axis, not the x-axis, down here, right? So it's y-axis, sorry. Yes. This is the original graph. So reflected, yeah, about the y-axis. I'm right. This one has to be fixed. It's about the y-axis, right? Yeah, y-axis. So you place the mirror here, and the new graph will be this mirror image, right? About the y-axis. Yeah, this is the rule, right? So we're talking about this guy. Very good. Moving on, guys. Another computational one, e raised to 1.2. You should do it in your calculator, right? Leave it for you. There's a problem, 64. Also computational, right? You have to let t be just this number, right? 14. You compute this 14, goes into this function as t, right? So I'll leave it for you. Similarly here, h must be just 11, right? Let's go over the logarithmic functions that we were talking about in the last lecture. How to solve this exponential equation. Well, we explained different methods, right? But one of them is this, right? If you can figure out how to express these two numbers using the same base, you should do it. For example, 4 raised to 1 is 4, 4 raised to the second power 16, 4 raised to the third power 64, 4 raised to the fourth power 256, right? You can run the powers of 4 and you will see that this 256 can be written as 4 to the 4. I noticed these two bases are the same, so the exponents ought to be the same, right? Because these exponential functions are one-to-one functions. So you set equal the exponents, and from there, the answer should come out, right? Should come out dividing both sides by 3, x equal 3, right? Not that difficult. I see a comment on the chat. Yeah, can very good, can, excellent, right? Yeah, we'll head there. Yeah, this one is similar, but I will give you the hint here so we can continue. Run the powers of 3. This is 3 to the 4 power, and write it up here. 3 to the minus x equal 3 to the minus 4, right? This is running the powers of 3. Yeah, very good, guys. So 9, 3 to the third is 27, 3 to the 4, 81. Yeah, very good, And then just minus x equal minus 4. From there, x equal 4, right? Yeah, very good. Excellent. Now we talk about these applications to finance, right? We said that there are two possible scenarios, two formulas. One of them deals with a situation when you your interest is compounded over some finite number of times in a year, right? Use this formula. And if they talk about continuously compounded interest, you use this other formula, right? So for example, here, if you just do this, the first number 68, if they say that you invest $9,000 at this rate 4% as a decimal 0.04, right, over n, they are saying semi-annually. N means, it means this has to be 2n, right? 2, because twice a year, 2 here, n, and 2 times the number of years, t, 10 years. If you do this computation, guys, I want to kind of refresh your mind. This process, right? You just have to do this in your scientific calculator or in your Desmos scientific calculator, right? So you get this. Carefully here, raised to. I would advise you to use parentheses for the exponent, so you keep these two factors together, okay? Yeah, I'm getting in trouble. So 13,373.53, rounding by default, right, to the nearest cent, right? This is what you do when you deal with money, okay? By default, 373.53. In the end, you attach the units, dollars, right? So we are talking about choice B, right? Excellent. Very good, guys, very good. Now, this is for a finite number of times for the compounded interest, right? But in case you see, yeah, and as a hint, right, if you see quarterly, n equal 4, right? But if you see the word compounded continuously, this word is important. We explained that this word tells you that you have to use this formula then, right? This formula. I will explain why, right? So we're going to use this formula now. A equal P investment multiplying E Euler number raised to R multiplied by T. A accumulated value will be present value 4,000 times E Euler number. R is here 8%, but we write 0.8, right? This in decimal form, multiplied by time. By time in years, 4 years. So this, right? This is what you have to compute in your calculator and approximate it to the nearest 100, right? Yeah, because we were up to cents. So 4,000 times E. Where is E, professor? You click function and it's here, E raised to, right? E raised to, use parentheses for your exponent, 0.08 times, go back to main menu, times is here, a 4, close parentheses, right? And you will get your answer there, 5,508.51 rounded to the nearest 100, right? Yeah, so this guy is 5,508.51 dollars, right? Dollars, and this is this guy, right? Excellent. Yeah, someone wrote something on the chat. Oh, no, everything's clear there in the chat. Yeah, so this is an example for interest compounded continuously, right? Yeah. Very good. This is similar, so you can do it at home. Similar. This one deals with comparing two types of investments, right? You can do this at home too. Let's try to look at the logarithmic equations now. This deals, is very easy because it deals with rewriting this in exponential form. For that, you just have to snail it, right? This, right? And you get here 6 to the third equal to 116, which is this, right? So this is good, easy, similar. Computational, right? Use your calculator here. So I hope at this point you will be okay. Remember, when you try to take a log of a negative number, nonsense. So you gotta go with this, right? Recall. Yeah, we have reached this part, the logarithmic functions. What is log base 2 of 7x minus 4 equal log base 2 3x plus 3? What is x? Whenever you solve a logarithmic equation showing the same base for the logs, you are allowed to drop them, right? Let's say that, and just keep the arguments right there, and you set them equal to each other. From here, you can solve this linear equation and get that 4x minus 4 equal 3. Adding 4 to both sides, 4x equals 7, dividing by 4 both sides, x equals 7 over 4, right? 7 over 4. Always check, but remember I gave you a shortcut. When you check, you don't have to go all the way till the end. It is enough just to make sure that when you are checking your answer, the arguments here must be positive numbers, right? Yeah. 7 over 4, yeah, great. Equal, is this equal to log base 2 of 3 times 7 over 4 plus 3? Look at this, guys. This is 49 divided by 4 minus 4. 49 divided by 4 is more than 4, right? So this whole thing is positive, right? Right? But positive number. So, and this one is also positive, the sum of two positive numbers. So if they're positive, they will check, we say, right? So just take it and then that's it. Or if you have time, you can go all the way down. You will see that you will get a perfect match there. Very good. So this checks, and therefore 7 over 4 should be a good solution, right? Very good. All right, guys, that was one example. Let's move on. Let's look at other examples here. Yeah, great. This one perhaps, yeah, but it's the same idea. You drop these two, you make this equal, you get the solution you check, so similar. Some graphing here. Yeah, I hope you will be okay with this. The graph of this part is just log base 5 of x. It's just this guy, right? Remember? Meeting here at 1,0, right? But then this minus 2 means you have to move these 2 places, 2 units to the right. Remember, this is counterintuitive, right? So as a result, you're going to get this point now, which is 1,0 at 1 plus 2, 3, 3,0. Now the point of intersection, right? So farther, 1, 2, 3 now, right there. And the vertical asymptote here, which was at x equals 0, now it will be at x equals 2, right? So here. So not hard to see, guys, that the new graph should look like this, right? Something like this. This shifted 2 units to the right for number 79. That's this guy, right? Yeah, this guy. This. Very good, very good. This one similar, okay, similar. Apply a vertical shift by 2 units down, right? Yeah, we'll be okay with this, I believe. Computational, use your calculator using the function ln, right? So computational as well. This one probably deserves some little attention. What is log base 25 of x equal 1/2? Snail it, right? Snail it, and the solution will come out there equal this. But what is 25 raised to 1/2? Is the square root of 25? But what is that? It's just 5, right? 5. 5, of course, checks here because it's positive, right? When you put it here, 5 is positive. It was good. So good. Therefore, this one, after checking good, that's it, 83. Let's move on. Yeah, let's look for more form. This one easy to, this is e, once you snail it, e to the third x, right? E to the third, that's after snailing it. Very good. This one, computational, use the change of base formula, remember, for this, okay? Use change of base formula. base formula. Right? You can do it at home. Yeah, this one is simplifying. It's also easy, right? Maybe we can do this quickly. Log base 6 of 6x equal log base 6 of 6 plus log base 6 of x, applying the product rule, right? But this turns out to be just the number 1, right? Because 6 raised to 1 is 6, and this stays as log base 6 of x. So we're talking about this, right? Yeah, great. Yeah, these one are all about properties of logs, so I think you will be okay with this. I want to reach this part where we have to do the condensation to solve this. Yeah, this one is also properties. Yeah. This one probably is good. No, but this one equal basis, so we did that, right? So yes, x plus 8 equal 1, setting the basis the same, but let's look for one. This one. 3 raised to 4x minus 1 equals 16. What to do there? When you cannot write both sides using the same base, I explained take logs in both sides, right? I'm going to use natural log, but you can take also common log, right? That's no matter. Once you do that, bring this up front, 4x minus 1 up front, natural log of 3 here, natural log of 16 here. Divide both sides of your equation by natural log. These are just real numbers, right? Treat them like real numbers. So 4x minus 1 equal natural log of 16 over natural log of 3. Add 1 to both sides. 4x will be natural log of 16 over natural log of 3 plus 1, right? And dividing by 4, you should get your answer, right? Dividing by 4 both sides. So your answer will be natural log of 16 over natural log of 3 plus 1 over 4, right? Put all this in the calculator, and then you should get your answer for 99. See? Yeah, very good. 98, 99. It leads to 0.88 rounding, okay? So this is here. Great. This one's similar, right? Taking like logs in both sides. Let's reach to a part where we have to do some condensation. This one, for example, right? What if they give you the sum of two logs equal to 2? I explained condense, right? Condense. Convert this to log base 4 of x plus 5 times x minus 1 equal to, right? Using the product rule in reverse. Then snail it. You will get that 4 raised to the second power is equal to x plus 5 times x minus 1. This is 16. This, once you fold this out, is x squared minus x plus 5x minus 5, right? Simplifying, you get this for x minus 5. Subtracting 16 in both sides of the equation, you get 0 equal x squared plus 4x minus 21, right? Factoring, 7 and 3 are the numbers, right? Minus 3 plus 7, so that the sum is 4. From here, you get these two candidates, right? X equal 3, x plus 7 is x equal minus 7. These are candidates you must test, right? When you check x equal 3. If you put 3 here, look, this will be positive, this will be positive, so this should be good, right? This is good. The inside of the logs are positive, but with negative 7, there is trouble because negative 7 plus 5, negative 2, there we are in trouble, right? So when you do the check, x equal minus 7 is not going to check because it's giving us negative arguments, right? So this is the only one. So therefore we choose this, right? For 103. Yeah, very good, guys. Excellent. This one's similar, but the idea here is to do the condensation via the quotient rule in reverse, right? So let me show you this. I'm gonna write here similar. I'm gonna show you this, okay? Similar to that. So condense this, condense, but now using the quotient rule in reverse. This guy on the numerator, this guy on the denominator, right? That equal to 2, right? Now, and I'm using division because this is subtraction, right? It's because of this, right? Before, maybe I should just kind of use colors here. Before we did, because of the addition, we did a condensation via multiplication, right? But when you have subtraction, you use division here, right? Yeah, this. Very good. Now, it's nail it, right? It's nail it nicely. It's nail it. You're going to see that 4 raised to 2 should be equal to the inside of the log the argument, right? So you're going to get this. 4 squared will be equal to x minus 2 over x minus 5. 4 squared is 16, right? Minus 5. Now we're going to solve for x. I am going to multiply both sides of this equation by x minus 5, the denominator, right? The denominator. Professor, why are you doing that? Well, because I want to eliminate this guy, right? And here I will have 16 times x, 16x, right? And then I will have 5 times 16 is negative 80, right? You may use your calculator if you need help with the computations, right? And then subtracting x in both sides, I will get 15x positive, right? 15x. Here, 15x minus 80 equal negative 2. Adding 80 to both sides, I'm going to get that 15x is equal to 80 minus 2, 78, right? Divide both sides by 15, x equals 78 over 15. Simplify, divide by 3, right? Here you will get 2 and 6. And here 5, right? Yeah, you can do this with a calculator, right? I show you how in Decimal Scientific Calculator, right? But you get it. Now, also, you have to check that this is not going to give you trouble here, right? Notice if I put 26 over 5, which is approximately equal to 4 something, right? For more than 4. That more than 4 minus 2 is going to give me a positive number here. And that is going to give me also a positive number here because it's greater than 5, right? Greater than 5. You can check, right? Yes, check. X equal 26 over 5, and you will find out that this really checks here, this equation. So good. Okay. For 105, A, very good. This one probably should be, I had 2 more, and then we're done. Let's try this because for the sake of variety, what to do if they give you something like this, natural log of 8 plus natural log of x minus 1, all equal to 0, the sum. Well, condense using multiplication, right? When you see the sum of 2 logs, you condense using multiplication. That is equal to 0. Professor, I don't see the base. The base for natural log is e, right? It's understood, not written, but it's e. Now you nail it. Just nail it, right? This is telling us that e raised to 0 should be equal to a times x minus 1. But e raised to 0, since e is a positive number, is approximately equal to 2.71 something, right? E raised to 0 is just 1. In case you forgot this fact, you can get it in the calculator, right? 8x minus 8. From there, add 8 to both sides of the equation. You will get that 9 is equal to 8x, right? And still cancel these 2. And dividing by a both sides, you will get your answer. X equal, so you cancel this 2, x equal 9 over 8, right? They wanted it in exact form. Now you're dealing with a logarithmic equation, right? So don't forget to check. So check. But I said, right, when you do the check, do this efficiently. When you do the check, just make sure that the inside of the log is positive. Is enough with that. Look, just make sure that this guy 9/8 minus 1 is positive, right? And I would say so because 9/8 is more than 1, right? So 1 subtracted from this will be bigger than 1. If you don't believe that, just compute it. Or you can compute the whole thing and you will verify that this is equal to 0. So 9/8 minus 1 is a positive number, small but positive, right? So that's enough, right? But now, guys, if you want to do a full check, you can always do this natural log of 8 plus natural log of 9/8 minus 1, 0, right? 0, perfect match, look, 0, right? You check, this is good. So means this is good, okay? So we're gonna go for 9/8. Very good, excellent, guys. Yeah, very good, guys, very good, very good. Yeah. Let's see what's coming up next. Another one, this is similar to the one that I just did, right? And this one also we did something similar. So we're good to go, I think.